Alright, hello everyone, thank you for being here. I'd like to introduce to you Blarg, but do not stop right there, we're not going to introduce Blarg yet. A little bit about me. Like most people in this class, I'm a senior here at Grandview. This is one of the two capstone projects I've been working on for this year, the other one being at the Cherry Creek Innovation Campus. I did complete a Grandview capstone project in this class last year as well, which I attempted to make a remote control plane. Didn't work so well. I learned a lot for sure. I have taken both AP Computer Science classes offered at this school right now, and I've taken Cybersecurity 1, 2, and 3 at the Cherry Creek Innovation Campus. I'm involved in clubs such as Cyber Patriot and the Computer Science Student Network at CCIC, and I have roughly 6 years of tinkering with programming. I earned my CompTIA A+, Network Plus, and Security Plus certifications, which are various IT and cybersecurity certifications, and I'm familiar with a whole slew of languages. This fall I will be attending CSU for the Computer Science program. And of course, none of these projects are complete without an advisory committee to help you as you struggle through this project. My expert advisor is Eric Van East, a senior software engineer at SAP Hybris. My other advisor is my dad, who is a principal network engineer 3 at Charter Communications, and then 3 in-class advisors, Grant, Ty, and Lewis, who have been very helpful as I struggled through this very fun project. So, Blarg. My project was to create my own programming language, which sounds complex, and it is. So what I wanted to do was I wanted to create a compiled programming language which compiles to assembly language. What this means is I'm creating a set of rules for my language, and then I'm creating a compiler which converts my language from Blarg into some other code. In this case, I intended to target assembly. It was going to be inspired by the syntax of C#, Python, and JavaScript, and I wanted to write my compiler in C. I knew from the beginning of this project, this was not going to be a finished project. It's very complicated, I don't have that much time within the school year, and I have a lot of other things going on. But the big thing is, I wanted to have a learning experience of doing this. There are so many languages out there already that adding one more is not going to have a significant impact, but I still wanted to learn how it works and get more experience in this area. So the primary objectives for this project were to gain a better understanding of programming languages, to learn how low-level programming works, and to develop a partial programming language, otherwise what have I done this year? I also wanted to focus on maintaining an organized project without procrastinating on it, which I'm sure most people in this room can attest to. And I needed to actually connect with advisors for once, because last year I had some trouble actually getting an advisor. So when I was planning out this project, I made a simplified timeline. It goes in more detail in this, but I simplified it for the presentation. And I broke into 5-week chunks here. So the first 5 weeks, I was just going to focus on entirely researching what I was actually doing and how assembly language works. The next 5 weeks, we focused on developing the lexer of my compiler. And the next 5 weeks after that, the parser. And the last 5 weeks, due to my experience from my previous project, I left entirely buffer room for everything going wrong, which inevitably happens in these projects. In case everything magically went perfectly, I had plenty of plans of things I could fill the time with. Creating some demo programs, configuring an IDE so it actually works with Blarg properly, and optimizing my code and the output code. And then, of course, extra time for presentation prep. So, diving right into what I actually had to research and learn for this project, I need to figure out what is assembly language. It doesn't make much sense to most people because most people here are programmers. So assembly language is a very low level of programming, perhaps the lowest most developers will encounter in their careers. And it directly corresponds to machine code. So rather than other languages like Python, where I can just write some very simple code saying hello world and it just works magically, there's a lot more that goes into this in order to interact with the memory of a computer in order to make certain things happen. So that means it communicates with the hardware directly by interacting with the memory and then telling the operating system what to do. So an assembly uses an assembler rather than a compiler in order to generate machine code, because it's a slightly different process to convert assembly to machine code than some language to assembly or machine code. So here I have an example program in assembly. This is just to say hello world. If any of you have programmed before, you'll know this looks a lot different from anything you've seen before. That's because it's a lot more complicated, like I said. Rather than just saying print hello world, I have to tell the operating system what I want to do and then provide that message in memory to it. So I kind of highlighted a few key points here. If you see where it says MOV and I have a circle there, that means I'm trying to assign some data to a specific register, which are these things here. A register is essentially memory of a CPU. It works similar to RAM, but it's on a CPU and it's much faster. And then a syscall here just means that I'm telling the operating system to do whatever instruction I've set in memory. And so now I have some basic understanding of how assembly works. I need to figure out how do compiled languages work. Because I'm trying to make a compiled language. What am I actually trying to do? So what's really happening is I'm having some program written in Blarg, like this code here. This just says hello world. And then I have my Blarg compiler, and that turns it into my output code, which was intended to be assembly. So it's not really that complicated on the surface, right? Because I'm just using one program to convert this to this. It's just like a translator. Turns out compilers have a bunch of steps to them. So if I put my source code in here, it's going to go through 6 steps before I get my output code. These 6 steps are lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and final code generation. So starting with lexical analysis. We usually call that the lexer of the compiler. And it focuses entirely on tokenization. So we want to take this program here and make it simpler for our program to understand, right? For our compiler to understand. So we're taking all of these words, we're converting them to a series of numbers. That's much easier for our program to use and manipulate as we move forward. So we're using a simple table here, which is telling us what each thing corresponds to. So if I have a function right here, like this word that says fun, that stands for function, it means 1, so I get a 1, and so forth. Then, moving on to the syntax analysis, the parser of the compiler, we're going to first look at grammar checking. So we're going to look at our program and see if it meets the grammar expectations of our program. So if we look at this sample program, and I add some extra word there, blarg, and then I tokenize that, and I get this extra 0 here. The lexer doesn't know what that's supposed to be doing, it doesn't really care, it's just trying to turn into numbers. But then here, we're actually making sure it meets what we're expecting. So this does not fit the syntax of blarg, because it doesn't end with a smiley face, and it doesn't assign to anything. It's just a random identifier there. So the syntax, the parser, the syntax analysis phase, is going to look at that thing and say it's an unexpected token, because that's not supposed to be there. It's confused why it's there. So it's going to stop compiling and tell you to fix it. Now, if everything looks good, then we're going to move on to building an abstract syntax tree. An abstract syntax tree is essentially a map of our program. So we take each significant part, say this function, and then using the show command, and we're putting this into nodes, and then we're relating these nodes to each other in order to build a little map of what's actually supposed to be happening in this program. And then the next phase, semantic analysis. So we're going to be trying to make sure that this makes sense, really. So if I add a variable here, right, I have the variable called hello that is supposed to be an integer, and then I put a string inside it. Well, the semantic analyzer is going to notice that this doesn't make any sense. Why would I put a string into an integer? So it's going to throw an error and tell me to fix it before I continue compiling. This just makes sure it helps debug some basic things before you actually use it. The last 3 are all related to code generation and optimization. So first, we're going to generate some code based off of our abstract syntax tree we've checked already. We made sure it's all good and ready to go, so we're going to generate some code. Now, programmers are usually stupid. So we're going to optimize this code and make it a little bit more smooth and less bloated than it needs to be. We can remove things that are redundant and just make it more streamlined. And then we're going to generate our code again just to make sure it's already cleaned up and ready to use. And so, for example, I take this abstract syntax tree, and I realize what I'm trying to do, and I make this assembly code. So there's a lot of steps to this, and I don't have that much time, especially since I know from my previous project that time flies in this. So I decided I don't really need these middle 3 steps, because even though they do some important parts, they don't necessarily prevent the compiler from working. They just make things easier to use. So this is something I could put off till later if I had extra time. So I took out these 3 key parts, lexical analysis, syntax analysis, and final code generation, and I targeted those as my actual compiler for now. And so now what I know what I want to do, I want to create a Blarg compiler using C that compiles to assembly. I need to find out, how do I do this? I've never done anything like this before, I've never used C before, never used assembly before, I have no idea where I'm going, what I'm doing. So I looked to the internet, because the internet has all kinds of wonderful things on there, and I found a compiler on GitHub called MiniC that converts C to assembly, and it's also written in C. This is fairly similar to what I'm trying to accomplish, so I figured I could draw some of the ideas and how this works from MiniC. So now I've finished some basic research. I'm looking at actually working my project. So starting with assembly, I started by looking at 3 assemblers: the net-wide assembler, NASM, a flat assembler, FASM, and an assembler called YASM. Wonderful names. So I did look into all of these, and I actually tried to use the flat assembler and the netwide assembler, yet both of them I struggled to actually get working and write code in. I ended up trying to focus on NASM the most, because it seemed it was the best maintained, I could find the most examples readily available on the internet. However, I had continuous issues, again, installing and setting it up and trying to just tinker with it. I couldn't get anything to really work. And then I realized after 4 weeks that this was way too much of just a time sink. I was not getting anything out of this. And I needed to change my project a little bit. Plus, who needs assembly? Then I started moving on to my Lexer, because I reorganized my project a little bit, decided that I would not compile to assembly, I compiled to C. C is something I have a bit more familiarity by now that I started messing with this. And I know I can probably do that since it's actually a programming language, not just assembly language. And so I started out by basically just copying mini-C. I was doing what they did to see if I could get something to basically work. And then I ended up redesigning it 3 times, because mini-C sucks. There's a lot of things that seemed really inefficient about it, and I just didn't like the way that they tried to parse certain things for large syntax. So I redid some of the way it does things in order to try to streamline it a little bit more. And I had many errors caused by just simple inexperience. I had never used C before, or any language like C before. C is considered a low-level language by today's standards. They've only used high-level object-oriented languages, which C is neither. So I had a lot of very simple errors that I spent way too much time trying to figure out, even though I should have known how to fix them if I had just known C already. These errors are simple things like just trying to read my source file. I found that when I was trying to read it, I was grabbing a few extra characters, and I was very confused, and I was ranting to Grant about that a lot. And it turns out that the file length I'm retrieving is not the same as the actual length of the content, because Windows adds extra characters each new line. It's a really weird issue. And it was causing some weird crashes and bugs in my Lexer, and I spent several weeks trying to figure this out until my advisor Eric told me that I'm being stupid and it's really not that hard. And then I moved on to the problem of using pointers. So pointers are a key part in lower level languages. C++ and C use them predominantly, and they make things a lot more efficient because you're able to pass the same data to a variable without changing it. And essentially, it lets me reference certain spots in memory where data is contained. And so, it's a very critical part of C, and I can't even make strings without using pointers. But I had no idea how to use them, and I kept doing things wrong and doing things backward, and then causing some weird memory errors, where just by printing a variable, I completely changed what happened. Essentially, I was corrupting the memory of my program. And then, besides all that, the Lexer is just so repetitive. It took me so long to actually decide on a way to do it all, and then I had to do it 34 times. Because each token has to be parsed in a unique way based off of the way it's supposed to be formatted. So I had to go through and create a new way of parsing it 34 times. And then I moved on to my parser. I started out again by following mini-C, and I only had to redesign this one once. Mostly because I didn't have time to redesign it again. I was getting close to the end of the project, and I realized I really need to hurry this up. So, since I've learned a bit about C from my Lexer and learned my dumb mistakes, this didn't actually take that long to put together, even though it's a longer file than the Lexer. The biggest thing that took time here was deciding the structure of my abstract syntax tree. I went back and forth on this for several weeks because there's no real set way of doing it. There's a lot of recommendations, but there is no standardized way of doing this because it's unique for every language. So after some time I came up with this thing, which is a struct. I used a lot of structs in my program, and a struct is basically a collection of variables in C. It's not quite the same as a class, but some people have compared it to that. And essentially I'm using this to create those nodes I was talking about in my abstract syntax tree, and then linking them together here. And so again, to reiterate, a lot of my roadblocks were some very simple things. Like, I don't know any language like this. This is completely foreign to me, and it was really, really dumb problems that I got stuck on for quite some time. And as part of that, I took on way too much to start. I thought I could create something that could go from my language, which was supposed to be a high-level language, to a very low-level language in just over 20 weeks. And yeah, that's not going to happen. I also had a lot of issues with just setting up my environment and getting this to work. School computers are a little fickle with how to access command prompt, but found ways around that. And then also just generally bugging and being new to C again. That was my biggest time sink here. I had so many dumb little bugs that were caused by me just having no experience in doing it. And so, now that I've finished this project, I had a revised timeline, which looks fairly similar because of all this extra time I built in here, but definitely pushed back a lot. So weeks 1 to 4, I was still researching assemblers, and by week 5, I realized this was a terrible idea. I need to change my project a little bit. And so I spent week 5 just trying to restructure my project and decide how I was going to continue from now. And I still spent week 6 then to 13 trying to develop my Lexer, and then weeks 14 to 19 trying to develop my parser. And then week 20 was me just cramming to fix some bugs, finish up that parser, prepare my presentation, and at the very last moment cram in some actual code generation so I can say it works. And so I actually do have some outcomes here, some good outcomes. I did create a compiler that can turn some Blarg code into C code. It's far from complete, as I expected with the beginning of this project. It can make Hello World happen. It can't do a whole lot else other than just consuming the computer's memory, so yay! I do definitely plan to continue this over time. I think it's a fascinating project, and even though I know it's not going to have much utility, I think I've learned a lot, and I think it's really cool. So using my sample code here, all I have to do is run this command that I built from my code, that I called Blargify, and I input my Blarg file here, the hello world.blarg file, and then once I build it to an executable, I can just run it and I get hello world. Yay, it works. I spent 20 weeks on this. And here are 5 of the files that are just a big mess and super tiny code you can't read. Out of my 9 files I end up using that are all roughly 100 lines long. There's a number of 400, 500. But anyways, thank you all for listening to my presentation. A bit more abstract than some of the other ones. I don't have much to really show you because it's a software-based project. But are there any questions? Grant.
Does Blarg stand for anything in particular?
Oh, yes, I forgot. Blarg is the better language for automation repetitive garbage. Type.
Why did you choose C instead of C++? Because it eliminates a lot of the problems.
Yeah, I knew that kind of from the beginning that C was going to be a pain because I never used it before. It wasn't object-oriented. I still did it anyways, despite the advice of basically everyone I know. Because I still think I learned a lot. I figured out how a lot of this works, and using a low-level language really did teach me a lot about the kindness of object-oriented programming languages. Yes?
How did you come up with the idea for the project?
This was entirely just because I've been tinkering with programming for a while, and I really wanted to know how this actually worked. I've been asking these questions for a while. It was hard for me to kind of understand how it all worked without actually getting into it myself.
Did this make you more interested in programming as a career?
Honestly, I think I can say more. It was a fun, frustrating project, but I did learn a lot, and I think I appreciate the experience I had.
So, do you think that you could use Blarg in systems that have to be like low level, as in that can't have a lot of added on padding?
So Blarg is actually intended to be a high-level language. I didn't really come up with any specific applications for it because it's so generic that it doesn't really do much right now. Technically, you could use it for anything to use normal programming language for, but it is a high-level language, so it's not always best to use those for low-level systems programming.
Would you say like past Capstone experience helped you a lot? Or, like,
Yes. Yes. I think knowing that everything was going to just collapse under me, I knew that from the start, really helped because I built in those extra 5 weeks of everything's going to go wrong, I can fix things now.
Are you ready to switch your major to computer engineering?
No, I'm good. I'll stay with this. Last year's project turned me off of computer engineering, that's for sure.
If you had like 3 more weeks, is there anything that you want to polish up or add?
If I had 3 more weeks, I probably could have actually put together full code generation because the thing is, once I actually got to that point and understood what was going on, it wasn't actually that hard. I just needed to push through to that last point.
Does it work on Linux?
It is currently not developed for Linux. It would not run on Linux currently.
What's your methodology behind the smiley faces at the end?
Oh yes, if you saw that wonderful syntax, a smiley face at the end of every line, that way when you get errors, you get a little reassurance that you're doing something right.
What would you say would be good for, like, how you would use this and, like, coding, like, let's say a website or games or really anything? What would you recommend?
Yeah, so again, this wasn't really designed for any specific purpose. It was really just a learning experience. There are definitely some things I can think of in other languages that I can simplify in Blarg to make it a lot easier to use for other purposes, but I haven't really done much of that right now. Yeah, I've thought about that. The big point was I wanted to compile it to executables because I wanted to learn more about that side of things. Because I don't really interact with that usually. Most developers don't, so.
Sorry, one more thing. If I had a space between the colon and the parentheses to make it like a big smiley face, will that error?
Yes. They have to be right next to each other. They have to really happy. So.
It's not smiley.
Again, thank you all for listening. This was a bit more abstract and less to look at, but I hope it was still interesting.